Alright, in this video we're going to look at position distance displacement and the position time graph, and a couple different ways we can graphically represent the motion of an object in position and time. So we have Frodo. He's stuck in Moria. Notice the first graph we're going to graph Frodo's position. The second one we're going to graph time, and then we're going to combine the two together two-dimensionally in position versus time graph. So Frodo is in Moria, they're stuck, and all of a sudden the orcs and trolls invade their room. I think that's where Thorin was buried, his tomb. I'm not totally sure, but I'm guessing that was the case. So let's track Frodo's motion as he tries to escape. So first thing Frodo does, we're calling Frodo's initial location the origin or the reference point at time 0. So it takes him a second to react. So 1 second goes by. He starts at position A, and then at event B, he begins to run to the left, where he moves 5 meters to position C, and that takes him, say, 5 seconds. So from B, which is at 1 second, it takes him, now let's say, yeah, 5. 1 second to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. So at 6 seconds, he's at position C. At that point in time, he spies the orc bearing down on him. He stops. Takes him a second to get his bearings and turn around. So 1 more second goes by. Now he's at 7 seconds in, and he begins to run the other way. So he goes back this way to positive position 5 meters. And let's say that takes him only 3 seconds because he's moving pretty fast. So 1, 2, 3. So at 10 seconds, he reaches event E, in which case he sees the giant mountain troll. So he stops again. In shock, it takes him 2 seconds this time to actually turn around and head back to where he came from. So he heads back to the middle, and then he waits for his friends to bail him out. And let's say it takes him 4 seconds to make it back. So from F to G, 1, 2, 3, 4 seconds goes by. So we can plot his position on the position graph, going back, waiting, back to the right, stopping and coming back. We can also chart how long it takes on a timeline from A to B, B to C, C to D, D to E, E to F, F to G. Now let's combine these together on a two-dimensional graph that shows both his position and his time. So he starts at time 0, position 0, and it takes him a second to react. So you know what, I need a scale here. Let's keep this consistent. So this will be 2 seconds, 4, 6, 8, 10, 12, 14, 16, 18, 20. So for the first second, he doesn't move, so his position doesn't change in that time. So from A to B, does not move, so his position time graph is flat. And then from B to C, he goes to position -5, and it takes him 5 seconds, from 1 second to 6 seconds. So at 6, he ends up at -5. So I'm going to mark that point C. And let me change colors. I'll go blue for his motion. So he begins moving, comes down, and then stops. So from B to C, he's moving backwards, right? Well, then he stops and sees the orc. So from C to D, it takes him a second to realize what's going on, so he's not moving for that 1 second, so his position time is flat. Then he begins moving back to the positive direction. He crosses 0. So from D to E, he's moving from position -5 to +5, but let's see how long that takes. From D to E, he's moving pretty fast now, so he covers that ground in 3 seconds. So at time 10, he has to make it back to +5. So he goes, whoop. So by the time we reach E, 10 seconds has elapsed, and he's back at position +5. That's the time in which he sees the mountain troll. Boom, it takes him 2 seconds to react. From 10 to 12, he's not moving, so his position stays flat. Then he hightails it back to where he began, so he moves from position +5 back to 0, and from F to G takes him 4 seconds, so from 12 to 16. So that's G. He's back at his original position of 0. And because he's moving, I'm drawing the line blue. So notice on the position time graph, the flat lines mean no motion. That's where he's staying in place, not moving at all. A downward sloping line means he's moving in the backwards direction, or in the negative x direction. An upward sloping line means he's moving in the forward direction, or the positive x direction. And the steeper the slope of these lines is indicating a faster speed. So how can we get displacement and distance off of this graph? Let's do a little example. Well, let's say, what was the overall distance that Frodo traveled? All right, well, he started at position 0. He moved 5 meters to the left. Remember, we don't care about the direction with position, it's just overall odometer reading. Then he moved back to 0 and all the way to +5, so he moved 10 meters to the right, and then back another 5. So he moved a total of 20 meters. So his distance traveled was 20 meters. What was his displacement throughout his trip? Well, delta x means where did he start and where did he finish? Well, he started, or final minus initial. He started at position 0, went down, forward, and back, and ended at 0. So his overall displacement during this trip was 0 meters. Notice, I can get that from this graph as well. I start at 0, I moved down to -5, and then back up to +5, so that's 5 plus 10, then back to 0 plus another 5, that's 20. So if you add all the distances traveled off this graph, you can get the distance. Displacement, he starts at 0, doesn't matter what his path is, he ends at 0, so his displacement is 0 meters. I'm going to give you guys a quick practice on interpreting graphs. So I'm going to throw this up on the screen. Here is a motion of an object. Whoop. Let's zoom that real quick. Okay, so I want you to describe or to identify during which intervals is the object moving in the positive x direction, during what interval are they moving in the negative x direction, and during what intervals are they not moving at all. So pause the video right now, write down your answers to 1, 2, and 3. Now I'm going to flip it and give you the solutions.